Welcome to multiplying a fraction by a whole number. For these three problems, you're going to need your notes packet given out in class and 2 to 3 colors. The first problem you should have is 5 times 1/3. We're first going to look at what does this problem mean. Well, hopefully you remember what multiplication means. Multiplication means repeated addition. So I can rewrite 5 times 1/3 as 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3. I have 5 sets of 1/3. Well, what would I get if I add those together? I have a common denominator of 3, so therefore my denominator stays 3 when I'm adding fractions. I'm going to add the numerator. 1, 2, 3, 4, 5. I have 5/3. What kind of fraction is this? It's an improper fraction. We're going to look at how can we take this same problem, draw a picture of it, and represent it on a number line. I want you to see if, as we're going through these, you can come up with some sort of shortcut for this. And we'll discuss the shortcut in class. All right, so let's draw a picture. I'm going to kind of do the same thing. I'm going to draw 5 sets of 1/3. 1, 2, 3, 4, and 5. As you can see, I have 5 sets where there are 3 blocks in each set. I have not yet shown what 1/3 looks like. So I'm going to take one of my colors and I'm going to shade in 1 block in each set. And that 1 block represents the 1/3. So I have 1/3 5 times. Well, now let's combine them to actually see how much we have. I know that 3 make a whole, so I'm going to draw a whole piece. And I can see that clearly I'm going to need more than 1 whole piece, so I'm going to draw 2 of them. Back to my colors. I have 1, 2, 3. These 3 are going to make 1 whole. So I'm going to color that one in. And then I have 2 left over. So I'm going to color in 2 out of the 3 on the second one. I still have the 5/3 that I already discovered up here, but I can also see that as a mixed number, I have 1 whole and 2/3. I've confirmed my answer in 2 ways. I still want to show one more way, and that's doing the same problem, but on a number line. So I can place 0 anywhere on the number line. I just need to make sure I have enough space for this problem. This problem isn't going to use the entire number line, so I think I'm going to start with 0 here. Remember, number line is a snippet. The number line goes from -infinity to +infinity. We're only looking at a portion of our number line. Since I'm looking at 1/3, I'm going to count on my number line by 1/3. So I have 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. I think I'm going to stop it there, but I could certainly continue my number line if I wanted to. Notice that these were written as fractions and then as improper fractions. I wanted to do that to keep the idea of the number line in my head. At 3/3, what is that? Well, that's 1 whole. What is 6/3? Well, that's going to be 2 whole. So I'm showing those as fractions, but also their equivalent whole numbers. Now I want to look at actually counting by 1/3. So I'm going to count by 1/3, and I'm going to do this 5 times. 1, 2, 3, 4, 5. I've taken 5 hops. Each hop having a value of 1/3. I can see that I again end at 5/3. I can also see, since I put my whole numbers in here, that 5/3 is going to be the same as 1 2/3, which I've already discovered up here. I have 1 whole and then 1/3, 2/3. I can also look backwards and say that 2 whole is over here, so if I take 1 away, 1/3 away, I'm still at 1 2/3. So I've confirmed my answer in 3 ways. If you're not with me yet, that's okay. Go ahead and pause or rewind if you need to catch up. Otherwise, we're going to move on to the next problem. Our next problem says 4 times 3/4. So what does 4 times 3/4 mean? Well, kind of like the previous problem, it means that we're going to do 3/4 4 times. You could also see this problem written as 3/4 times 4 because multiplication is a commutative property, which means that the problem could be written either way. So 3/4 4 times is going to be 3/4 plus 3/4 plus 3/4 plus 3/4 plus 3/4. So I can get an initial idea of what my answer is going to be. Again, I have a common denominator, which is going to stay as 4. Then I'm going to count by 3s. Oops, I noticed that as I'm attending to precision, I did 5 3/4, not 4. So luckily, I can fix that before I get too far into my problem. I would have figured it out, but later on, but here I figured out earlier, which is better. So now I have 4 times 3/4, and I did that by looking back at my problem to make sure that these matched. It didn't match, so I needed to fix something. So 4 times 3/4. So I have 3, 6, 9, 12. So I get 12/4. Again, keeping that common denominator. So let's draw this. How would I draw 3/4 times 4? Since 4 make a whole, I'm going to outline 4 boxes. And I have a whole number of 4, which means I'm going to do this 4 times. Now I need to go back and actually color in 3 out of the 4 boxes. This represents my 3/4. But I'm still not quite sure how much I have. Well, I can count and see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 1/4 pieces, which confirms my answer up here. But I want to see what this might be as a mixed number. So I know that I'm going to have to take some of these and fill in the missing spots. I see here that each one has 1 missing spot. So if I take one of these and I put this one, fill it in there, this second one I fill in over here, and this third one I fill in over here, that takes care of everything here, and I should have 3 whole. Let's check. So 1, 2, 3. I already know that I should have 12 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 spaces. Here's my first 3, and then I'm going to take this end one and fill it in to make a whole. I'm going to fill in these 3. This middle one, I'm going to put over here to make a whole. My last 3, And this last one, I'm going to fill in over here to make a hole. I see that this is equal to 3 whole. Now I want to do the same problem on a number line. On my number line, I'm going to have to count by fourths. So I think I'm going to put my 0 over here. I see that I'm going to be going up to 12, which is going to be pretty far on my number line. So I need to start pretty far to the left. So I'm going to write 0, and then I'm going to count by fourths, just like I did with the last problem, and I'm going to go into improper fractions. Then I'll go back and write my whole numbers in. So 0, 1/4, 2/4, 3/4, 4/4, 5/4, and I'm going to keep doing this. I think I'm going to go up to 16/4. I like to go a little further on my number line than what I've already shown as the answer, just in case I made a mistake in one of these. I have additional room to work on the problem. So go ahead and fill in your number line with me. Okay, I have it filled in with my fractions, going into improper fractions. Now I'm going to go back and put my target whole numbers. So 4/4 I know is 1. Then 8/4 is going to be 2. 12/4 is 3. And 16/4 is 4. So now I'm going to show on my number line the hops. So I'm going to go 1/4, I'm going to go 3/4 4 times. So I can actually kind of count by threes. 3, 6, 9, 12. So 0 to 3/4 is 1 hop. Now I'm going to count 3. 1, 2, 3. I see I'm going to go to 6 next. 2 hops. 1, 2, 3. 3 hops. 1, 2, 3. 4 hops. So I did 3/4. Notice there's 3 spaces here. Each has a value of 1/4. 3/4 4 times. And I see that I still end at the same values that I've already come up with. Is there a shortcut? See if you can figure it out. If you need to, pause or rewind. Once you have this problem done, go ahead and try 3 times 5/6 on your own. In class, we'll go over the answer to this, what you may have drawn. Hopefully, you all have come up with a couple different ways. We'll also come up with these shortcuts to the first 2 problems.